Today is a continuation of a study of the mole. And today we're going to be discussing how is molar mass considered in a mole. Previously, we learned the two conversions that 1 mole of any substance is equivalent to 6.02 times 10 to the 23rd units. Another conversion factor that we used was 6.02 times 10 to the 23rd units is 1 mole. Well, I'm sure none of us want to learn how to discount every single unit there is of any particular particle. So scientists have found out an amazing concept about the mole. We can use the grams. If you notice up on the board here, I do have a periodic table. If you don't have a period, if you can't see it, please take out your periodic table now, and you'll be able to utilize that in determining. Let's look at some numbers. Let's look at some numbers that are out there. So I want everyone on there to look at oxygen. If you'll notice that there are numbers in here, again, use your key if you're not familiar with what it's all about. So I'm going to utilize oxygen in my example. And oxygen is number 8, which means it has 8 protons in it. And it also means, if you look at that red number up there, which is the average atomic mass, it says that the average atomic mass is 15 point, oh, I can't read it either. I think it's 9994. Maybe another 9 in there. All right. AMUs. And remember, an AMU is an atomic mass unit. An atomic mass unit is based on the carbon-12 isotope. So knowing that, we can determine how the mass, that means the mass of one oxygen atom is 15.9994 AMUs. Cool, huh? But we don't measure AMUs in the regular high school chemistry lab, do we? We measure grams, and even then we have to measure like maybe to the nearest thousandth of the gram, which is still pretty small, but not as small as an AMU. So scientists have learned something really great about it. And they say, well, what about a mole? Well, let's use that concept again of what a mole is. Again, a mole counts how many particles it is, but a mole does so much more. Here's another example. Let's go back to that. The scientists have found out that 1 mole of substance equals the molar mass. And you're going to ask me, okay, what's molar mass, Mrs. Wells? Molar mass is actually the number of AMUs, but they're in grams. Do you believe this? We know that 1 mole of substance is the mass of the AMUs adjusted to in grams. So 1 mole of oxygen actually has a mass at, of course, standard temperature and pressure, a mass of 15.9994 grams. No new numbers to remember, same tool we get to use, but now we know that 1 mole of oxygen is that many grams. So I can look at anything. If I can look up for nitrogen, how much is a mole of nitrogen? What's its mass? And you would say, oh, let me look. And I click on my periodic table and say it's 14.0067. And I'd say you're right. So we're going to go look at more conversion factors. This was our original conversion factor. So we're going to say the molar mass, kind of redundant here, is 1 mole. Or 1 mole is equal to the molar mass. Again, more conversion factors. Let's take time to do another example about this. All right? And we're going to use just the ones I have on the board here. Again, if you have your periodic table handy, that would be awesome. As we erase this a little bit. So I'm going to let's use sulfur. According to mine, sulfur has has a molar mass of 32.065 grams. Again, using your periodic table, you can find that on there. It's not very clear right here. So, what does this mean? It means 1 mole is equal of sulfur equals 32.065 grams. Now I'm going to use this as a conversion. Let's say, suppose I said, we're going to try and do a few more moles. I want you to figure out 2.5 moles. If I have 2.5 moles of sulfur, how many grams do I get? So with that being said, with how many grams I'm getting, if I have 2.5 moles of sulfur, using a factor conversion table, dimensional analysis, if I have moles of sulfur up here, the label I must use here is moles of sulfur. I know 1 mole of sulfur is 32.065 grams. And then I would use my handy dandy calculator and determine how many grams of sulfur I have. So let's do that. Take some time, solve it. If you want to pause the video now, you may. .5 I'm typing in times 32.065 is equal to, I'm going to get this number right here, 80.1625 grams. Again, we need to be conscientious of significant digits. Yes, the dreaded significant digits. Because I gave you a starting number of 2.5, this only has 2 significant digits, therefore my answer may only have 2 significant digits, so my correct answer is just 80. I'm going to put a decimal here. You remember why? Grams of sulfur. Okay? How's that sound? Let's try one using maybe another compound. Let's go backwards and see what we have. Maybe I'm going to give you some mass. Let's see, if I give you some mass, let's figure out how many moles that is. Again, using the factor conversions. We're going to use our second set now because we've been working on that first set of conversions. Let's look at that second set of conversions and maybe let's work with chlorine. Is everyone, can you find the molar mass of chlorine? That's right, it's right up here in this corner. In my periodic table, if you have a different periodic table, please look for that. Use your legend or key to find that. Let's suppose I have 100.0 grams of chlorine. How many moles? When solving these problems, always start with the number that is given to you in the problem. So I have 100 grams of chlorine. I look for a factor conversion I can use. Now, because I have grams of chlorine in the numerator, I must consider that when what factor conversion I'm going to be using. My factor conversion must have grams of chlorine in the denominator. So I look at here, factor conversion says, okay, if I'm going to have mass, I have 1 mole on the top as in my numerator, and my mass is in my denominator. So I place 1 mole up here of chlorine, happens to be 35.453 grams. As I go ahead, remember, these are symbolic. I don't like to add a lot of extra symbols to it, so I use the dimensional analysis with this grid board. So I take 100 times 1, which is 100, divided by what's in my denominator. Again, take some time. You can pause the video and figure this out and see if you get the right answer. And the answer is, that I obtained, is 2.820635771 on my calculator. Again, we cannot use this number as it stands because we have taken consideration the significant digits. I'll go back to my original problem, my original number that I gave you. It has how many significant digits? Because this 0 is after the decimal, all zeros are counted. So it has 4 significant digits. Therefore, my answer must have 4 significant digits. 1, 2, 3, 4. Right here. Because it's a 0, I look for the rounding. For the precision, I look for the rounding. Is that 6 going to turn that 0 into a 1? By gosh, it is. So I end up with 2.821 moles of chlorine. We're starting out learning these conversion factors as we move on, because we always have to follow that law of conservation of mass. And so every gram, every atom, every molecule, every formula unit must be accounted. So let's look and see if we have a better understanding of what to do. Do we understand how moles and molar mass are related? Do you understand how moles and particles or units are related? Let's go one step further. One more type of problem before I will stop the video and you can do your practice work as assigned in your homework. Let's suppose I give you particles and I want to find out how many grams. Let's suppose I give you 1.473 times 10 to the 24th molecules. Maybe we don't do molecules. Let's just go with a simple thing. Units or atoms of neon. And I want to find out how many grams. So let's go ahead and do that. I set up my original problem as 1.473 times 10 to the 24th units of neon. Again, labeling is important. Can you get by without labeling? No. Because this number is in my numerator, it has units of neon, it has a large number, it tells particles. I'm going to have to use this factor conversion first. So the first factor conversion I'm going to do, if I have units in the numerator, what must I have in the denominator? I must have units. So I'm going to say 1 mole is 6.02 times 10 to the 23rd units. As you can see, my labels cancel off, and I'm left with moles. But is that what I want my final answer to be? No, my final answer must be in grams. So from that, if I have moles up here, I'm going to go to that factor conversion and put 1 mole here of neon. And I'm going to say, okay, what does 1 mole of neon have a mass of? And you're going to go, I can look on my periodic table and I can find out it is 20.1797 grams of neon. My moles of neon now cancel, my labels do, and you can see that I am left with grams of neon. Is that what I want to find? Yes, it is. That's my goal. Whatever I end up with the top numerator should answer the question in the original problem. So if you take some time now, you're going to remember how to use this. If we don't remember how to use it, let's take that calculator underneath the video and remember how to plug those numbers in. Many times it's really handy to have those parentheses working for us. So I'm going to start with the parenthesis, 1.473, and I'm going to use that EE button, which is the second function usually on there, and says to 24.
You can't see it because of the glare.
Of the glare?
Yeah, you can't see your calculator.
Okay, I just was informed you can't see the calculator, but...
You want me to turn off this back row of lights?
Yeah, that'd be, well, I think all the lights should be turned off. Thank you to my assistant. Okay? Okay, we're going to put the other parenthesis in. So that's my first number. I'm going to take it times the other number that's in the numerator, 20.1797. I'm going to press that equal sign. I'm going to get some outrageous number. And then I'm going to divide that by, again, I'm going to use those parentheses around that Avogadro's number, using that EE function, and equal, and I get a 49.37657492. Again, we cannot have that as an So we look at our original problem, we see we have a 1473 as a significant digit, so our answer must have 4 significant digits. So in this particular one, and if you can't see, when you're doing your calculator work, you need to count, you have the 4, the 9, the 3, and the 7. After the 7, there is a 6. That would round the 7 up to an 8. So I would get approximately 49.38 grams of neon. So you need to, as you need to, review this video to find out how to convert in these areas. And remember, whatever's in your numerator, to get rid of it, it has to be in your denominator. So take that in consideration when you do your work.